So as you know, my world is standards, right? That's where I live and breathe, which sounds a lot of fun probably to everybody, but actually I kind of like it.
Somebody has to do it.
Somebody has to do it. Might as well be me. For those of you who are science teacher people, hopefully you are familiar with our 3 dimensions now within our new science standards. Math, we have a 2-dimensional learning, right? The practices and the content. In science, we have 3 dimensions: practices, content, and our content is in 2 different forms. So our practices are similar, there we go. So our science and engineering practices are similar to our math practices. And then our content lies in 2 different zones. The disciplinary core ideas, which is sort of the science concepts that we've been teaching for many, many years. But then they also have a second set of content, which we call cross-cutting concepts. And these are overarching ideas that cross boundaries in life, earth, and physical, but also cross boundaries interdisciplinary as well. And so you will see things like systems and system models, scale and proportion and quantity, stability and change, patterns, cause effect, those types of things. So today, we're actually sitting in the middle of a science and engineering practice. I mean, smack dab on top of it, right? So we're going to look at analyzing and interpreting data, which is our science and engineering practice number 4. Because it is so closely related to number 5, which is using mathematical and computational thinking, we're going to just look at that. We're not going to spend a ton of time in it, but I think it's worth just taking a peek at today. So that's the science connection. There is a huge math connection. So here are your 8 math practices. So those of you who teach math, you're probably very familiar with these. If you are engaged in analyzing data or making sense of data with students, you're going to be doing at least some of these, if not all of them at one time, right? You're going to use appropriate tools to collect the data. You're going to model things with formulas or graphical interpretations. We want to construct arguments and critique the reasoning based on our analysis of our data and make sense of problems as we persevere in trying to solve them. We're having this overarching groundswell problem we need to solve. So you're going to be doing a lot, if not all of these, in our math world too. So that's where groundswell is really nice, right? Is it's got that interdisciplinary piece. And if you teach language arts, Ted, we have a lot of pieces, and I did the 3rd through 5th and K through 12, 6 through 12 pieces from the Common Core. It's kind of ridiculous how well it fits into when students are actually using an analysis of data. They have to use, students have to use information. This thing is a little bit dead here, but use information from illustrations, maps, photographs. That includes graphs in language arts. If you aren't familiar with that, any type of thing that they read or analyze is part of text now in the Common Core for language arts as well. They're going to interpret information presented visually, orally, or quantitatively. That's also a big deal in analyzing. Drawing information from multiple sources, digital sources, including some of that stuff that you're going to pull with Janet's stuff today. So it's data. When you get into 6th through 8th, 12th grade, they actually go into some of the science and social studies pieces that we're asking students to do in language arts. We're doing that in math and science. Authors' claims. Students are going to be making claims based on their data. We've got multiple sources again, integrating multiple sources in diverse formats. There's your data, specifically quantitative data there. Evaluating hypotheses, coming to science conclusions, which is the point of data. Synthesizing information from multiple places. So we are hitting on a broader topic than what it sounds like when we are looking in that analyzing data world. We're hitting a lot of stuff. Okay, if you haven't seen this before, this is the famous Venn Diagram that links all of the math, science, and ELA standards together in one beautiful little diagram. And what this does is shows you where things overlap. So if you're doing one, you're doing another type of situation. So you can see where the math and science overlap at the top, where ELA and math and science and ELA overlap. And in the middle is where all 3 overlap. And what you'll find in the middle are typically using rich text, speaking and listening, constructing arguments and reasoning, and engage in the argument from evidence. And those pieces are what students are going to have to do with the data to make sense of it.